Welcome back. I just want to take a quick minute to honor your dedication and hard work in this class. Electricity scares a lot of people, and for good reason. So I admire your taking the time to understand what's going on with this invisible and powerful subject. In this lesson, we're studying the electrical properties of amps, or current, the flow of electrons. Amps are kinetic energy, or energy in motion. Amps are the kinetic energy part of electric power. Electric circuits start with a power source, static energy, or volts. Enter Joe's water tower. Let's say the work here is to get a glass of water out of Joe's water tower. If there aren't any holes in the tank, how can I get water out? Well, I can't. Not until I put a hole in the tank. I have plenty of static energy, but zero kinetic energy. No flow. This is the electrical equivalent of an open circuit. Where does the energy go? Well, it's not going anywhere until I pop a hole in the tank. Okay, now, let's say the work here is to fill up these two swimming pools from Joe's water tank. I pop a pinhole in one side, and I put a big old 4-inch hole in the other side of the tank. Which hole will fill the swimming pool faster? Yes, the 4-inch. Obviously, more water will flow through the bigger hole and fill the swimming pool faster. The pinhole has more resistance and therefore enables less flow or less current. What work gets done? Well, the swimming pools get filled. And where does the energy go? It goes to ground. Okay, now the same work scenario. The job is to fill both pools from Joe's tank. In this scenario, both sides of the tank have the big 4-inch hole. But on one side, I attach a 4-inch diameter hose, a big one, and on the other side, I connect a weeny 1/2-inch garden hose. Will the big 4-inch hose or the little 1/2-inch garden hose fill the pool faster? Yes, correct. The bigger hose enables more flow and will fill the pool faster. The resistance to the flow of water, or the limitation to work getting done, in this example, is now in the garden hose because the pinhole in the tank has been upgraded to a 4-inch hole to match the other side. Notice how electrical resistance can appear in different parts of the circuit. This scenario is analogous to undersized wiring. All electrical wire has a limited capacity to accommodate the flow of electrons, and when that capacity is exceeded, the resistance in the wire creates heat. First, the insulation melts off, then the wires start a fire. Proper wire sizing is critical, life-saving even. If you're going to be designing electrical systems and sizing wire, I highly encourage you to check out my wire sizing classes. This class is a prerequisite for it. If you had to put out a fire, which hose would you choose? The 4-inch hose that can deliver 240 gallons per minute, or the 1/2-inch garden hose that can only deliver 7 gallons of water per minute? Obviously, you'd grab the bigger hose that can deliver the power that you need and when you need it. Conclusions. We see here that the properties of electricity, amps, and the resistance, ohms, share an inverse relationship, meaning the higher the ohms or the resistance to the flow of electrons in a circuit, the less current or amps will flow through that circuit. Conversely, the lower the electrical resistance in a circuit, meaning big fat wires that can handle the current and good, clean, tight electrical connections, the more electric current will flow through the circuit. Something else we're learning here is that resistance can and does occur in different parts of the circuit and at different times. Switches can be a source of resistance when they start to wear out. Ever had to replace a faulty switch? What happened to it? Well, for whatever reason, the resistance in the switch increased. Maybe it got wet and corroded. Or maybe it just wore out from use. Or maybe it wasn't sized correctly and melted. What do I mean by not sized correctly? Electrical systems that work properly and don't start fires need to be engineered, meaning you need to do the math. You need to be able to identify and calculate volts and ohms and amps in the circuit to know what's going on and to make sure your components are up for the job. Results of averting this process can be devastating. The ability to identify all the points of resistance in an electric circuit and to find unexpected resistance in a circuit is an invaluable skill to someone troubleshooting electrical systems. More on finding resistance and troubleshooting in the next lesson. See you there.